A major impact from a comet would have devastating effects. Imagine the following scenario. Scientists have spotted an 8-kilometer-wide comet on a collision course with Earth. It's too late to stop it.
The first thing you'll know is when the sky lights up and the ground shakes.
Brilliant meteors streak across the sky as the giant comet's debris strikes the Earth's atmosphere. Forests catch fire, ignited by the superheated air. When the comet hits, the blast kicks up millions of tons of fiery rock and dirt. The airborne debris blankets the planet and blocks out the sun. Day turns to permanent night, bringing freezing temperatures and year-round winter. It takes more than a year for the dust to settle and sunlight to filter through the clouds. When it does, the Earth starts to warm quickly. Elevated levels of gases created by the fires turn the planet into a sweltering greenhouse. Millions of species of living things that survived the earlier cold cannot take the heat. They die. It takes thousands of years for life on Earth to recover. How great are the odds a comet will strike the Earth?
Will another impact occur? You bet. It's going to happen again. The Earth is sitting out there with a bullseye on it.
The chances of a major impact in our lifetimes may be slim, perhaps on the order of 1 in 100,000. But astronomers the world over are working fervently to understand these strangers in our midst, struggling to learn what comets are and where they come from. Mankind's ultimate survival may depend on our ability to stop one before it strikes. In the 17th century, stargazers observed how some comets orbit the sun in regular intervals, like the planets. One astronomer even predicted the return of the comet that now bears his name, Halley. But no one knew what they were made of or where they came from. As late as 1950, astronomers could only guess at their true nature. Fred Whipple, the father of cometary astronomy, envisioned comets as flying mountains of frozen gases, ice, dust, and dirt. He called them dirty snowballs. He theorized that as comets neared the sun, they shed dust and gas as their ice vaporized, forming their signature tails. It wasn't until the 1980s that astronomers were able to test Whipple's theories by approaching these speeding ice balls. What they discovered surprised them. In 1985, as part of the International Sun-Earth Explorer program, they flew a spacecraft loaded with sensors through a comet's tail. In 1986, the European Space Agency sent a craft called Giotto to study Comet Halley's nucleus. The scientists feared the debris flying from Halley would destroy Giotto. It didn't. The craft not only withstood the pummeling, it sent back amazing photos of a cratered sponge-like surface with jets of gas shooting from within. Suddenly, scientists began to wonder exactly how rock-solid comets really are. In the year 2000, they got more clues. On its approach to the sun, a comet named Linear unexpectedly blew apart. Earth and space-based telescopes captured the explosion, allowing scientists to analyze the chemical composition of the nucleus for the first time. That information, combined with data from the earlier flybys, confirmed what astronomers were beginning to suspect. Comets are not ice-hard. They are surprisingly fluffy, porous, and fragile. Johns Hopkins University's Hal Weaver simulates the comet's unexpected makeup.
Okay, we're going to make one of the most primitive objects in the solar system, a cometary nucleus. these cotton balls are just barely held together. One of them just fell off. And as comets pass through the inner solar system, they get heated up. And sometimes these little cotton balls just fly off and break apart.
Comets consist primarily of chunks of water, dirt, ammonia, and carbon, molasses in this experiment. They are permeated throughout with frozen gas, what we know as dry ice. As comets near the sun, the ice vaporizes, releasing gas and dust that form the characteristic tail.
You see the ice subliming, going directly from the solid phase to the vapor phase. This is exactly what happens when a comet is going around the sun. It doesn't look like your original concept of a comet, does it? But it's a single solid object. You can see active regions on the surface bubbling up. We get activity only on specific spots for a lot of the comets. And as they fly by through the inner solar system and heat up, sometimes chunks just drop off. And sometimes we see the comet completely disintegrate.
This new knowledge about the fragility of comets may seem reassuring. How can they do much damage? But as they race through space at more than 11 kilometers a second, even small comets can spell disaster. Donald Yeomans studies comets for NASA's Jet Propulsion Laboratory.
Well, they are fragile, and you could break them apart with your hands perhaps, but they're huge. You know, they're 10 miles in diameter, and so it doesn't really matter that they're fragile. They're so big that they've got a lot of mass, and it's mass and velocity that's important when they hit.
We can't stop a comet heading toward Earth if we can't see it. But that's another mystery plaguing scientists. Where do these cosmic travelers come from? Astronomers have long observed comets emerging from deep space. To know exactly where they've been, they would need to get their hands on actual comet dust, a record of a comet's birth and its travels.
3, green board all the way across. 2, we have main engine start. 0, and liftoff of the Stardust spacecraft.
In February 1999, NASA's Stardust spacecraft began a voyage to rendezvous with a distant comet named Wild 2. Its bold mission was to collect dust from Wild 2 and return it to Earth. By raising a giant gel-filled petri dish, roughly 30 centimeters in diameter, it collected more than 1,000 samples as it sped by the comet at almost 20,000 kilometers an hour. The mission was a remarkable success. In January 2006, 7 years after liftoff, Stardust's cargo capsule returned to Earth. The contents have been a treasure trove for scientists.
We thought comets all formed from stuff pretty far from the sun. We're finding in this comet grains that formed right next to our sun.
Born near Earth when our solar system was formed, the comet then fell into an orbit that took it far beyond. According to surprising new data from Stardust, much farther than scientists once thought.
There's not just material from our own solar system at its birth stages, but also materials from different distant stars mixed in as well. And also materials forming far from it and just sort of like passing by. It's a real grab bag of things in our galaxy.
The story of the comet's origins begins 4.6 billion years ago. Our solar system is in the midst of a fitful birth. In the center, a cloud of gas and dust begins to contract into an immense disk. The disk's powerful gravity sucks masses of matter inward. Pressures and temperatures soar until the enormous dense ball ignites, its gases and matter imploding in nuclear fusion. A star, our sun, is born. Left to orbit the newborn sun is a fog of debris. The fragments careen into one another and clump together into celestial dust balls. Over millions of years, these monster clumps grow larger as they orbit the sun, until they form an array of planets, including our Earth. But some dust balls, future comets, do not merge and condense into planets. A billion or more slowly gravitate to an orbit between Neptune and Pluto, a region called the Kuiper Belt. Trillions of others are exiled partway to the next star, to a nebulous realm called the Oort cloud, hurled outward by the gravitational fields of large planets like Jupiter. They have elliptical orbits that vary greatly.
You've got the Kuiper Belt region of comets, and they're mostly compressed into a plate-like distribution. But in the Oort cloud, which is 1,000 times further out, they're in a veritable cloud. So you've got objects in this kind of an orbit, this kind of an orbit, that kind of an orbit. They're coming in from the outermost edge of the solar system.
Amazingly, astronomers did not confirm the Kuiper Belt's existence until 1992, even though it is part of our solar system. Today, they believe the Kuiper Belt is the outer range of comets with the most stable orbits, those that enter the inner solar system every 300 to 200 years. The best known of these, Halley, returns every 76. But it is the second region, the Oort cloud, 2 light years away, that troubles scientists most. Scientists believe an occasional disruption, like a change in a star's gravitational field, will eject a comet from this cloud. It can then fall under the gravitational pull of our own sun and start a journey toward our inner solar system, taking thousands of years. Scientists have no way to predict when these comets will appear, and they can come from any direction. One may already be on a collision course with Earth. For these fragile, frozen outcasts, every journey into the inner solar system is fraught with peril. Some will lose their icy payload and become dormant as the sun burns off their gases. Some will break apart as their icy glue melts in the solar heat. The fragments may continue to circle the sun, appearing to us as meteor showers or shooting stars. Some comets will enter Jupiter's orbit, drawn by its enormous gravitational field. The giant planet then slingshots the invaders back out of the solar system. But some will run full tilt into another heavenly body.